Okay, one moment here. Let's find. Is this what I'm looking for? There we go. All right. Sorry, I had to find the. Um, can I just go to. View in live control room. There we go. Okay, cool. Let's go to analytics. All right, awesome. Okay. So, hello everyone. Welcome back. This is Sentient Cloud. Still kind of figuring out some of the stuff here. So, anyway, back to the matter at hand. So I'm going to be working on that array implementation, and it's not going to be like some massive complicated thing. I'm going to make this fairly simple just because there's no need to make it complicated. Okay, so we'll do push and pop as well. So it's gonna do all the basic array stuff. And this is going to push and pop are basically just going to be the unindexed, just put it on the end of the thing. I don't need that. Okay. I guess for both push and pop, now we'll leave that in there. So normally the way I've seen push and pop implemented, you don't normally see it being able to take on multiple units of whatever data you're providing it, but I don't think there's anything particularly wrong with doing it that way, especially with how the underlying implementation works. So, okay. All right. Let's go here. So going to implement these two functions. Okay. Say that these return success. Moment. I'll need to add in some error messages for things like unable to remove stuff due to it just not being there. Okay. So all those are there. All right, let's start here. First things first. Let's see. So length cannot be 0. So let's start with that. I'm going to go ahead and include assert because sure. Just throw in a couple things here. So first of all, array cannot be null. Array must be on. And length must be greater than 0 constant length. Greater than 0. And I guess the same for stride. If stride is 0, then everything in this breaks. So definitely need to include that. And let's get rid of this debug because no one wants to be there. Okay. So let's go ahead and, so in this case, data can be null, and if you specify it as null, actually, I don't think it, I don't think it technically can. That's maybe I need to have some different functions. Because I want there to be the possibility of data being null, because I think it makes perfect sense to allow for someone to reserve a certain amount of space without having to copy data. I was watching a video done by the Cherno on YouTube, and he was talking about some of the misuses of vector, and this is kind of one of the areas that he talked about, where basically forcing people to copy data and to perform lots of little allocations are both ways to reduce performance. And so in this case, what I'm going to do is, if length can be greater than 0, it has to be greater than 0, I should say, but data can be null theoretically. And if it is null, then all that's going to change is that you're going to have the size not equal the length to start with, and the gosh, what's it called? Like there's not going to be any copying. It's just that the capacity is going to be set to a particular size. The space is going to be allocated for said capacity. So you get some nice stuff there. So let's go ahead and let's go and do this part. So first things first. Before I go any further, I need a standard implementation. And I'll say array list void. So this is going to have use size, length, and capacity, and actually, I need to make sure this is in the exact same order as the other ones. So I think it's first capacity, and actually, you know what I can do? Hold on, better idea. Okay. So we're just going to initialize that, and then up down here, we'll do array list void. So all that's going to do is give us, how to put this? I'm drawing a blank here. How do I just explain this? Basically, I need to be able to manipulate all the stuff, like the data and all that. Actually, hold on, change this real quick. There. So an array list void is going to provide me with a void pointer for the data, and it's going to do a bunch of other stuff. But the main point is that it gives me the ability to cast this to something that's not specific. That's what it's doing. Okay. So now I can do things like array capacity. And actually, before I do that, I'll do array data equals malloc. And then length times stride. So just give myself the data, and then capacity is going to equal length. Here, just make sure and check the data. Return mem error. Oh. Okay. Yeah. And so obviously if it fails to allocate, then you return a memory error and bad things going to happen. Okay. So capacity, that's fine. Next is the length. Now, the length is going to depend upon whether or not data is null. If data is null, then it's not going to. So let's go and we'll just have it check for data. Yeah, okay. Yeah, so we'll do it like this. Mem copy array data. So we just want to copy all of that in, and then set array length to length. So the array length and capacity are all counted in terms of the underlying data. So if you are making an array of integers, then it's going to say, and let's say you initialize it to have 5 integers, then capacity will be set to 5 and length will be set to 5. Right? It's not going to be set to 20 in order to count the underlying bytes, because in this case, I don't really want to force the person, in this case it's going to be me, using this at any given time to understand how many bytes of space their thing takes up. So there's that. Okay. I think that's all I need there, and we'll just go and make sure if we're not dealing with any data, then this is equal to 0. Okay. I think that's everything I need there. And then we'll just get rid of this debug again and put in if array. Oh, should I? Let's do this real quick. Array data. This should equal null. Yeah. Let's be null. So I want to make sure that I'm not screwing things up by trying to call array new on an already initialized array structure. So definitely don't want to do that. And I don't want to call array delete on an uninitialized one, but I do recognize that it's probably going to happen at least once. But so I'm going to go and just have it check for that. It's not this big imposition to check. But if it is there, then we'll do free array data. And then I'll just go and do memset array size of array. Let's go and make sure that's been dereferenced. Okay. So that should work. I need to go back to the header real quick. And I'm going to go ahead and make a few changes here. So this is going to be changed to, let's see, I guess array from. And then I'm also going to have define array reserve. So all this is, so we're going to do array length, and it's just going to call array new, but it's going to make a few minor modifications. So it's going to use null there, length, size of, and then same basic structure that we had before. Okay. And I think I might need to include as a stdef. Just to make sure that we have access to null. And let me actually, I need to open up tests real quick because I put in some stuff there that's okay. So array new no longer exists. And maybe actually I just use array new and array reserve instead of array from. Let's do that. So I won't change this part, but I will do array list int. Let me just make sure that's initialized. Now, one thing I am going to do is, for the most part, rather than putting the initializations of the array types in here, I'll probably try and put them into array.h, just so that I don't have to constantly redefine when I want an array, like a particular type. That just seems like it would be inconvenient, and there's no reason to. It's just going to add the same number of, like, it just seems like it would make more sense to include it in the header. Okay, so we have our array there, and then I'm just going to do this, make sure to specify that. Okay, so array reserve. This is just going to take array, and it doesn't need to be referenced. And I'm just going to go ahead and do, let's say 10. And I just realized that this should not be 10 here. That's bad. That should just be 2, because that's over allocating. Okay. Jeez. All right. Now, okay. So we're reserving space, and then we'll delete it. Okay, let's go back to containers. Contain. Jeez, I can't spell. Array.h. Just gonna go ahead and replace this with array new. There. Okay. I think that's everything. Okay, we got some errors. Declaration. Yep. Okay, so I need to include string. Well, now that's weird. Why is it not including that? All those are fine, nothing wrong there. Mem copy, that definitely needs to be fixed. Okay. Request for member data. Something. Okay. Dereferencing. Oh, right. Okay, I need to go ahead and specify. Hold on. This is in, so recreate it. Okay, so what's going on here is this. Make sure. And then all of these need to be specifying. Otherwise, it's dereferencing. Excuse me. Okay, and same here. Need to make sure that it is using an actual array type. Just go ahead and okay. I suppose actually it would make more sense to do it like this, because all the rest of the named ones are doing it this way. As you can see. Okay. Oh, shoot, can't use mouse for this. Done. Yep. Okay. Array data, and we'll just go ahead and specify here. Array data must be null. fix all of these real quick. Okay. Cool. So, alrighty. That should be fine there. Now I need to include string, like it said, because I need those copy functions. I realize this is like a small thing, but I'm not a huge fan of the fact that the memory functions are all in the string. Use struct type value. Oh, right. Hold on. Yeah, okay, forgot. This needs to be okay. Valid argument. Right, because that's in here. Gotta make sure pointer. Oh, there we go. Okay. Assertion array data must be null. Why is that failing? Okay. That's in test. So wait, yeah, hold on. I know why. Hold on. Because this should be not. Don't need it there. Tests ran. Okay. Nice. So, got a working create array and also reserve data. So, perfect. Let's move on. So, need to define all of these now. In order to do that, I'm going to define. I suppose I should probably put this into the header as well, because it's theoretically possible and reasonable for me to allow myself and people who are going to use this, if they ever do, to resize things after the fact. So let's go ahead and put in result score resize array size length. Okay. Oh, and stride. I gotta make sure stride's in there. Okay. So, and I should probably also put in duplicate since I'm here. Result array duplicate. Void source. Let's call it that. Okay. And stride. It does need stride. Okay. So. I guess that could actually be, yeah, that could be done with just a define. Hold on. Because really all I need here is, so we've got array new, array reserve, define array dupe. That's going to take one array, source, and that's it. And then it's going to do array new, array, then data is going to be source data. Length is going to be source length. I suppose you could make the argument that it doesn't. So instead, real quick, I realize this isn't necessary, but I'm going to do it anyway, just so that it actually does duplicate, not just. Oh, actually, hold up. Okay, so never mind. If I want that functionality, I'm just going to have to bite the bullet and actually make sure that the length and capacity are the same. Huh. Okay, how do I want to do this? I suppose I could always use resize. That would be this great imposition, I suppose. And just make sure to do size of array.data. So what I'm kind of internally trying to decide is, do I want the capacity to be copied, or do I want the length to be copied? The length, if I do that, then that means that the capacity is not going to be the same necessarily. Is that like a terrible problem? I wouldn't say so. It is certainly a concern. So, yeah, I don't know. All right, let's go ahead and get back to it. So we've got duplicate, we've got reserve. I'll have to test that duplicate, see if it actually works. But for now, we'll go back to actually making implementing the actual functions. Okay, so first off, result array, oops, resize, and then length. That's all that it needs. Oh, and stride. Forgot stride. That needs to go in there. Okay, now let's see. So I'm gonna need it to. Okay, so first things first, we'll do some asserts. I realize this might seem like a waste of time. You could make the argument that it is. I don't know if I totally agree that it is, because you'd be surprised how often people accidentally put the wrong thing in place. So we're just going to go do that. And then it must be non-null. And let's see. I suppose it is perfectly possible that the data... Oh, I guess no, that wouldn't make sense. So array data has to be non-null as well. These will all, because these are asserts, they will all get removed outside of debug builds. So it has to be things that are only... Like, this kind of stuff is going to have to be caught in testing. Okay. Let's see. Length needs to be greater than 0. And stride should be as well. So I basically just copy this entire thing with one singular alteration. So I just kind of wasted my time there. Let's go like this. Okay, great. So now, resize. So if length is less than capacity, actually no, if length is less than length, I should say. That's important. Because length in this array structure refers to the number of elements. Capacity is just the size. If the length I'm asking for is less than the number of elements, then I'm going to have to, truncate and remove those elements. Otherwise, it's not going to matter. So if length is less, then I'm just going to go ahead and say Can I reallocate for less memory? Hold on. Let's see. Reallocate less memory. Let's make sure that I'm doing this correctly. Reallocates given memory if pointer is not null. Must be previously allocated, that's fine. Not yet freed. Expanding or contracting. Possible, areas remain unchanged. Up to the lesser of the new null set. Okay. Theories expanded the contents of the area undefined. Okay. So I think I can allocate less memory. So really then the only thing, I guess actually I don't even really need to do much, do I? What happens if it fails? Return value. On success, returns pointer at the beginning of newly allocated. The return pointer must be deallocated with free reallocate. That's fine. Okay, so I have to make sure and save this reallocated pointer. So what I'll do is do void new data equals reallocate. Reallocate length times stride. Actually, I need to include data there. There. Okay. That's the, yeah, so it takes the pointer, and then all I have to do here is if array data does not equal, I should do it this way. First of all, new data is null, then I guess we need to just return mem error if yeah, so the original pointer remains valid. Okay. So that's not really new data, strictly speaking. That's actually, I guess, a result, effectively. So let's call it pointer. Okay, so if that's the case, then that's there. And so I think that's all I need to do. Everything else is copied over unless I'm mistaken. Copying data. Yeah. Yeah, okay. So that's really all I have to do there. And then if that's the case, then do that. Otherwise, if length is less than array length, then array length is equal to length. And array capacity equals length. Okay. Excuse me. Okay. All right, I think that's everything I need to do for the resize function. Just return success if all goes well. All right, guess next up is push. It's going to be pretty important. Okay. I suppose, actually, now that I think about it, doing build in public. I'm not sure I understand what you mean there. Like, am I making some kind of repository publicly available? Is that what you're asking? Okay. So we'll just go and do that whole assert. The assert tango. Am I building in public? I'm not sure I understand what you mean there. I don't think that you and I are. Yeah, I don't understand what you mean. Like, I mean, I'm writing code in a stream, so in that sense, I'm building in public, I guess. But I don't know if I understand. No. No, I tried it like once and never really used it after that, and I never got very far, so no. All right, let's see. So data can't be null here, so I'm gonna have to make sure that's specify that that's must not be null. Oops. So it must be not null. There we go. All right. So first off, if array length is greater than or equal to array capacity, okay, have a good day. We'll do it this way. So we'll resize, and we'll say do it like this. Okay, and then suppose we do something like while array length this feels weird, but I'm going to do it for now, and maybe I'll find a better better way to go about this in the future. So while array capacity times mult is less than array times equals 2. And then we'll do resize array capacity times mult. It's going to be a new size, and actually I should make sure to specify array and also the stride. Cool. Okay. I think that's all that I really need for that part. So we just want to make sure that whenever we're inserting a new element or new elements, because this can insert multiple, that it's going to actually resize appropriately. So in the event that we want to, like, let's say that I start off with a fairly small array and I want to insert, like, 15, 20 elements or more, whatever, that it will resize appropriately in one go, rather than having to do it multiple times. And I suppose, actually, now that I think about it, I suppose I could actually do something a little, well, no, because that's going to cause it to reallocate. Never mind. This is fine. This will do the trick. Okay, so let's go ahead and... Yeah, okay. So we need to push all the elements, so I guess mem copy array data array length. So just want to make sure to put all those elements on. And data length times stride. So this right here is just accessing that the end of the array length and then copying data over. And then from there, array length is just going to be increased. And I think that's everything that needs to happen there. And I don't think it's really feasible for mem copy to fail unless those are null, and neither of them are going to be null because I already checked that. Okay. Oh, actually, before I go any further, if array resize, I guess, hold on, we'll do try, because I already did that. I already made that function to do this, or it's not a function, it's a define, but that's okay. Okay, so also specify result, because that try relies on that. Okay, cool. That should work. And array pop, it's going to be somewhat different. So real quick, I need to go to defines.h. And here, I suppose I could just have it return a memory error. It is, in a sense, it's a memory error, so I guess I could do that and not have it be just hilariously unhelpful. Nope, not tanners. Use containers. Array. Let's see. Let's go back here real quick. And we'll work on the other. Pop is going to... Let's go like this again. Copy this down. And I'll need to remove a couple of these. So first things first. There is no data. Let's get rid of that. You cannot call pop with size of 0. I don't think that makes much sense. I suppose, actually, there's nothing like making that, terrifically bad. These two definitely need to be true. I don't know if I am going to, like... Maybe it doesn't really matter if... Like, it's not going to cause an error if length is 0. It's not like the end of the world. And it's just going to mean you're not going to insert anything. Which is bad, but it's certainly not like some great, terrible failing of the software. Yeah, because you could theoretically be in that position. Okay, so I'm just going to pretend like... I mean, not pretend, I'm just gonna, it's not gonna matter. doesn't really matter if length is 0 for this. It'll just mean that, nothing happens. I guess in that case, though, I mean, it's probably best for it to not, like, for you should check and see if it's actually gonna be 0, but I don't think it's some problem that I need to prevent here rather than doing stuff later. So we'll go with it. Okay. All right. If array length is 0, then return error. Actually, that doesn't need to be in there. Let's go with that. Okay. Else, we'll just say, actually, hold on. If array length is less than length, so I do want it to return 0 in that case, or not 0, an error, because of course you shouldn't be trying to remove stuff when there is nothing there, but it is still going to do its thing. So if, so what it'll do, hold on, like this. So it will return an error, but it will also actually just do the thing. So array length equals 0. Else array length minus equals length. Say if this is less than or equal to. Okay. Yeah, pop is much easier to do. Okay. We'll just throw in. Get rid of this. So nothing else is going to be modified here. I suppose I could also, you could make the argument that I should return the values that I'm removing, but I don't think that actually is necessarily the best idea. That seems like it's just going to open up the door to a lot of problems. And I can always access them beforehand. Yeah, we'll leave it as is. Okay. Insert. This is where things get slightly more complicated. So let's just go ahead and see. So first things first. Same basic principle applies here. So yeah, array data and data both need to be greater than, or non-null. In this case, once again, not going to worry about length, but index. Index is where things get interesting. So I'm going to do index has to be less than array length. The reason is it should be obvious. I think I have to do less than or equals. Because you could theoretically insert, although it would be somewhat foolish, you could theoretically insert at the end of an array. And in that case, it would basically just be the same as push. So you probably should just use push because it's just going to be easier that way. But, it's theoretically possible. I could see it happening, and it's not like it's an error. It's not going to, should cause problems. If it causes problems, then we'll change that. Okay. Index must be less than or equal to array length. There. Okay. So now we'll do basically the same thing we did up here. We'll just go ahead and copy all this stuff. It's just going to copy the the resizing portion of this, and then we'll do so I need to move all the stuff at that position. So something like oh wait, I can't. Oh wait a minute. Oh shoot. Okay, never mind. I think I need to make some modifications. Slight modifications. Okay. Oh, this is annoying. Okay. All right. So, minor modification here. Because I just realized a bug before, like an error that the compiler is going to tell me about before I compiled. Because I'm so very smart. I'm just such a clever person that I spent like probably half an hour without realizing what I had done. Okay, hold on. Let's go up to the top here. So this can go away. This. The reason for that, so I'm going to specify that these are all chars. The reason is void pointers can't be dereferenced, and they can't be treated like arrays. You can't access, you can't use the array access operators. So what that means is you are, or I am going to see an error when I try to do this. Now the reason that I like doing this is because it's a whole lot more convenient, syntactically speaking, and the compiler complains less about it when I do this, rather than trying to do array math, or pointer math. Right, pointer math, the compiler gets all mad at me because I'm using you know, this type of integer with that type of pointer, and it gets all annoyed about it. So I'm just going to use characters instead. And it's unlikely that I'm going to use character arrays. Character arrays are kind of an uncommon data structure, but it does the job that I want. So we'll do char there. ArrayList char. All those are ArrayList chars now. Okay. I'm going to go to the header real quick. And I'm going to way down here, I'm going to define ArrayList init char. So, and like I said before, all of the array types that I plan to use are probably going to end up being put here as well. Actually, I'll do U8. So yeah, do that. And then go back to containers. Because essentially, U8 is essentially a byte. Not even essentially, it is literally just a byte. That's, yeah. Okay, so we'll just replace these with U8. Now, I don't have to get yelled at when I dereference. That's going to save me some headaches ahead of time. Oops. Okay, cool. Alrighty, let's see, member move. Let's see, I want to go to plus index, I think. Array data index. Man. And then we need to make sure and move length times stride elements. And I'm sure someone at some point will probably wonder what's mem_move versus mem_copy. The difference is mem_move is for when you're moving within the same chunk of memory, and mem_copy is for when you are completely outside. So, fun fact. Okay, let's do, so what was it? Copy. I want to make sure and get data at index, and actually I should make sure that this is times stride. All of these are going to be times stride because yeah. Anyway, okay. Copy the data, and then that's going to be length times stride. And this is actually not going to be length times stride. This is going to be, let's see, is it array length minus index times stride, I think. I think that's what I want. This is the part that's going to take a lot of testing. Inserting in arrays is just a massive pain in the neck. You know what? I can actually save myself a little bit of hassle, or not really hassle. It's not really going to make things any significantly different. By just making the pop and push functions a define. I'll think about that. It doesn't really matter all that much. Okay. Let's see. Length is 0, then we can. Oh no. I'll just have it do its thing. Okay. So now array length. Okay. I also should probably include array print, like array to string, just so that I can like have something that works, like so I can like debug this a little bit easier. Because admittedly, I could test it like programmatically without printing, but I think printing is the fastest and easiest way to debug this. So I'm gonna have to define an array function that will make all the things. Okay. Okay. For now, I'm going to stop worrying about this array remove part, and I guess I can just do array print in the test itself. So let's go do that. Tests, test.c. Okay, so we'll get rid of this one. I don't need to define the same one because that's defined in the header. And I'm not using that, so we'll just do that. Okay, so for initializing it with data, let's go ahead and we'll just give it C and A. And then we'll do for, hold on. just going to specify this is going to take an arraylist char. For I zero less than array dot length. Jeez, screwing this up. Okay. Go ahead and say it's got that. Yeah. And then at the end we'll do new line. I suppose I could use debug for this, but I don't really want to. Okay. So print okay. Things are going to break. Oh, that should be, yeah, hold on. Yeah, okay. Say array u8. Oh, and this needs to include data at I. Size of data. Okay. C A. Okay, cool. Things are compiling. Now let's test this. So I'm going to call array push. We'll say array data. Let's give it something new. Like what am I building? Like in a larger, like the whole project, or what am I doing right now? So two different things. Let's call it data 2. Okay. So the whole project, I'm working on a text editor, like a graphical text editor. So, yeah. Data 2, length is 3. Let's go do size of data 2. Okay, and then index we'll say is, yeah, I'll say it's 1. Okay, and I need to go to containers. Oops. .h, and go in here and add line. Hold up. Array. Let's see. Data length index. And then size of data. Make sure that this is insert, because that's really the thing I'm most interested in testing right now. So wait, what? Huh? What on earth is going on? What the heck? Huh. That's weird, because it's never complained about that before. Hold on. What's going on here? Okay. So that's working. That is exactly what it's supposed to be doing. All right. So then what happens if I do this? Because it's mentioning before, but it might be the case that don't need to implement pop or push as their own functions. So we'll do index will be array length. All right, I'm just going to go ahead and do push array data 2 size of data 2. We'll do insert 1, and I don't need to include the index for that. Expected identifier before numeric constant. Definition, too few arguments. I think I need to do some research on pound define, because it feels like I'm constantly butting up against it. It's what do you call it? Its limitations. Hold on. Let's go to tests / test.c. Let's try size of data. Maybe that's why it's not happy. No? Okay. All right. Well, I am going to go. Yeah, okay. I'm going to go ahead and end the stream here. I need to do some more research on pound define because I'm constantly fighting with it, and that's rather annoying. So, thank you all very much for watching. I hope you enjoyed, and I will see you again probably tomorrow. So, have a great day.